morning, everybody. Well, it is morning here in the UK. Quite a grey, drizzly morning and quite cold. I hope you have better weather where you are. Welcome to Pearson and Edexcel International GCSE Science, in particular physics, and we're looking at getting ready to teach our new modular GCSE science course. Right. A part of today, we will have one of the Pearson people joining us, Tim Lawrence, and he's going to, I hope, be able to answer some of the questions if I can't. He is also, as you'll see at the end, I've got a slide with his details. He is also the point of contact if you need any questions from Pearson about science, and if he doesn't know the answer, he knows who to send the question to, which is always the best thing. So what are we going to have a look at today? Oh, by the way, I should introduce myself. I'm Pauline Anderson. I am what is known as a senior examiner for Pearson Edexcel. I have been examining for them since my daughter was 1, and she will be, I hate to say it, 38 this year. So I've been examining for a long time, a very long time. At one point, I was the person who wrote the linear exams in GCSE physics, international GCSE physics, and I decided that I decided to step down and do something else instead. I'm still examining, I'm still working with the teams. However, they've given me this job, which is to talk about the courses, explain the assessment models instead. So this is my retirement job, if you like, but I'm still heavily involved with GCSE and, for that matter, the A-level physics as well, the international. So we're going to have a look at today the modular course, and it is still not too late if you want to sit the exam this summer, but I think you're going to have to get a wriggle on because your entries have to be in fairly early. All right. I'm not sure how many of you have actually done very much of the prep work, but we're going to have a look at it. We're going to have a look at the course as such, and looking at the assessment objectives, how they fit in, how this course matches with the linear, and what are the advantages and the disadvantages of this. So this is some of the things we're going to have a look at. We're going to have a look at particularly at the overview, the content, how you can plan, practicals, oh my goodness, practicals, what we call the taxonomy, which is, in other words, another nice word for the command words. And then we're looking at the math skills in particular and the support from Pearson. Okay. So at some point, we will give probably around the halfway mark, I'll give you a short break so that if anybody's desperate to need another cup of tea or coffee, they can get that, or they can have just a quick dash to the bathroom, or even just collect something else that you need. You should have a resources pack, right? This is available at the bottom, and it says more. You should be able to get your resources pack. In there, we have given you all of the Pearson documents about getting started. In addition, you've got the delegates booklet, and you've got a nice little spreadsheet. And the spreadsheet is something that I'll come back to, which we'll need later on, and have a look at this. Okay, so what should we be aiming for in this session? Right. By the end of the whole meeting, I hope that you will know how the qualification is devised and how it fits into the existing qualification, how it sits next to them, so that you can actually see which is going to be better for your students. We're going to hope to have a look at the content, not in great detail because the content is very, very similar to the linear. And then we're going to have a look at planning the courses, planning the lessons, looking at the support. Now, some of the support is going to be about the practical and some of it is about the maths, because we found that these are things that people tend to forget or not play as much information about, because they are in fact, well, the maths is 30%. If you don't function around the maths, if you don't bother about teaching the maths and it's 30%, you're not teaching a third of the course. The practical is 20%. So if you're not teaching that, you're not teaching a fifth of the course. So in total, you're not doing your students a favor if you don't address these issues. Right. So let's go. Pearson, why Pearson? The Pearson isn't your only choice. But one of the things we do is that we have a large, if you like, support network. We operate worldwide. In March, I'm going to China. I'm going to Hong Kong. Just before Christmas, I went to the Middle East. A colleague of mine went down to Africa. So we are worldwide. Okay. We have representatives in most countries or in groups of countries. We have a Middle East representative and so on. So we do have a whole representative support network. In addition, we have contacts back at headquarters. As I said, I mentioned Tim. Tim is our contact and he knows who to ask questions about. So we have got you covered. We will be there to support you on your journey. Okay. Right, now let's get into the nitty-gritty. Modular. You're lucky. Home GCSE cannot have modular. One of the things that we have not been able to do is have a modular course. So all our students, all our 16-year-olds have got to do 2 exams at the end of year 11, and what they have is a mix of all the topics all in one go. For international GCSE, we have now got an opportunity to do a modular course. Now, this doesn't mean that the content is very different. The content is almost exactly the same. It's chopped up into 2 chunks. So we have got them in an assessment way that it might be useful. We have no opportunity. Assessment work at the end works. Yes, it works. And it was one of the government people, Mr. Gove, who decided we're all going to do linear a few years ago, and that's it, full stop, right? Most people, however, prefer that you have your pressure at different points. If you can have your year 10 doing half of the exam at the end of year 10, or even in the November of year 11, then it might be very helpful to them and it might spread the pressure over them. And furthermore, they've only got half of the content to learn at any one point, right? The journey length is almost the same. It doesn't really matter. It's a 2-year course. Some people will spread it over 3 years, and that's fine, right? That will very much depends on your school, your preparation, and whatever, right? But whether you do linear, whether you do modular, at the end, you will get an IGCSE. There will be a big overlap of content between the 2 exams. So in any one session, there will be an overlap of content. And I can show you the slide for that from a different presentation, actually, but I can show you the slide on that one. However you teach it, it should be the same length of time. It's still 30% maths, it's still 20% practical. Your assessment objectives, AO1 and AO2, are still the same balance. How we test it is going to be different, but the style of the questions are going to be the same. They're going to be they're going to be written so that they overlap. Right? And that's really important. So you know that the standard is going to be the same and it's still going to have the same recognition worldwide. Okay. Right. So we are the only international exam group which will offer a modular course. Right. The demand is going to be the same. The recognition is going to be the same. The qualification level is going to be the same. It's absolutely the same. Just different exams at the end or partway through, which is very useful, right? There will be some slight differences in the way in which we have got the grading. Now, because modular, you have, well, you have actually as many resets as you want to. We will always take the highest reset, but because you are potentially doing exams at different points in the course, what we will do is to change those grades into raw marks, or from the raw marks into a uniform mark scale, and we will assess them on that. Right. So the mark, if you're doing separate science, physics, your exam papers are out of 90. They will be converted to a uniform mark scale. And those, so whether you do it in November, whether you do it in June, those grades will be comparable. That's the whole point of a uniform mark scale. On the linear route, you take your grades are calculated on the raw marks at the end. Right? They're very, very, very similar in terms of number of marks. It's almost exactly the same. Modular is 290 mark papers. Linear is 110 and a 70. So they both add to 180. Same difference, but it's making it comparable, making them understandable. No resets in linear. You have to sit the entire lot all in one go. So if you want to resit, you've got to do paper 1 and paper 2 in November. If you're doing the modular, you can take just one of the papers. Right, if it's paper 1 or paper 2, you can just take that one paper, but you can't. There's only one reset available in linear. You've got to do the whole lot again, not half of it, which is a big advantage for many people. I don't know what the implication is in terms of fees for the exam, right? Students can hold their unit grades together until they decide to cash it in, right? Right. In a linear, they can only cash in at one point, which is at the end of the exam series. If they want to do a resit, it's a new series. Right. So you've got this rolling opportunity with the modular, which is, again, to many students is a big advantage. Okay, so this is where if you like, we are at the moment. Most of the people, the content was available from September last year, right? We have to have our entries in by the 21st of March, right? If you want to do modular this year, you have to have that in by the end of March. Okay. It gives you the unit code, and then their exam will be in June. That will be the first exam, Unit 1, right? And then August, the result will be available in the same time as the other posts as normal, right? Okay, in September, it can continue, if you like, continue the journey, right? For the, you've got another entry for November, and you will have an exam in June. So if you have year 10 at the moment, you can enter them at that point. Now, I did check and I thought that there was an exam in November, but I'm fairly certain there was an exam in November. But maybe Tim will be able to back me up on that and I can check it. Okay, some of the advantages, some of the disadvantages. Okay, I'm not sure where these slides are from. It looks like the tie looks as though it's in my old school, to be honest. When I was teaching in Norfolk, not when I was teaching in Zambia. As far as the students are concerned, if you are doing a modular exam, a lot of them do prefer to reduce the the mental load, the stress. They focus on the curriculum. It gives them an opportunity, if you like, I was going to say to demonstrate their skills, but I do know that, students of 15 and 16 can go down and be ill, can have a problem. It gives them the opportunity to work past that problem and do the exam at a more opportune time for them, right? As far as the parents are concerned, for some students and for some parents, if they have an exam halfway through, it gives them a check, right? It enables them to say, oops, I didn't do as well, or I can do a resit on that. So you've got what they call data, a rich mid-cycle data on the learner's performance, right? We have got Results Plus, we'll talk about later, which is really useful to be able to have a look. I'm not sure. My sister works as an exam officer, and I'm not sure she would agree with that. The exam officers, it reduces the pressure. It just gives them more opportunity. It spreads the load a bit more for them. Yeah. And if you are paying fees, then budgeting is actually quite an important thing as well. So there are some benefits to the students, to the parents. I apologize. Somebody has not done their work there. I can see that one. IG biology. Yes. Okay. I should have sort of whipped that one out and changed it. A bit late now. However, right. It is this. The content is in the structure of the course is similar for biology and for physics. In this case, we have got what we call guided learning hours. Okay, so we anticipate that over a 2-year course that students will have basically 2 hours a week of physics, and that they will do that for 30 weeks of the year. So that gives them 120 guided learning hours. So in year 10, it's probably longer. You probably got 35 weeks and then 25 weeks in year 11 or vice versa. So we have got this guided learning hours. We've got the specification. We've got a get started. We have got a scheme of work, the teacher's planners, the lesson plans with some suggested activities. You have got student books available, and there is, I don't know if anyone is aware of it, but there are student lab books available as well. There's an enormous amount of material on the website, and I do mean enormous amount, possibly too much to find. There will be exams in November and June. There will be resit opportunities without limit. The assessment, we've given you exemplar material, now the examiner's reports are quite interesting. There's obviously, we can't give you an examiner's report for an exam that's never been sat. But as soon as the exams are sat, you will have an examiner's report. And the examiner's report is one of the essential pieces of information that a lot of people forget. It tells you not just, well, students found this hard, or the candidates found this hard, but they will target you and they will say, this is what they were doing wrong. This is what they were doing right. And they will give you possibly clips from students' exemplar material that the students actually wrote in the exam. So if you're not reading the examiner's report, you're missing a big trove of treasure, because you can say, oh, maybe my kids were doing that wrong as well. Maybe that's the point I've forgotten. The past papers are very useful, and it's not just past papers for this, but past papers for the linear. And I would also contend you can also have a look at the same content in the home GCSE, not the international, but the home GCSE as well. There will be some overlap in the content, and the style is not going to be that different, right? It's not a bad idea to have something different there as well. We have Exam Wizard, which enables you to search the database of all the past exams, make your own exam papers, and have a good excuse me, and target the exam. Results Plus comes up after the exams. I am aware, and we are working on it, that some schools will have an opportunity, have more difficulty in getting Results Plus. And that's to do whether or not they enter via the British Council. Okay. So, okay, an opportunity. Excuse me. Do you think that the modular assessment will support your students? Okay, I'm going to ask if you can write this in your in the chat, which at the moment I'm finding difficulty in even looking on my others more. I haven't got my chart grid thumbnail. I think that the biology and the physics are actually quite nice, because what we've done is to take the content and we've split it into two. And basically, in the linear course, you had 8 topics. You had force and motion, electricity, you had waves, energy, solids, liquids and gases, magnetism, electromagnetism, radioactivity, and astrophysics. So you had 8 topics. What we have done is to take those 8 topics and we have split just one of them. We've taken the solids, liquids and gases and we've split it. So we've put solids, liquids and gases in unit 1, which is as you can see, it's also called unit 5 for double award, and we've also put half of it into unit 2. The biology is very similar in the sense that they've split it in the same sort of way. The chemistry seems to be more on a spiral, so it seems to be that virtually every topic has been split into 2. If your students are doing double award rather than separate sciences, then this would be unit 5, because unit 1 and 2 are biology, 3 and 4 are chemistry, so 5 and 6 are going to be the physics. If you've got a star against it, as you can see here, right, the stars are basically the content which is in separate science. There's a bit in each of them, but you can see that when we have a look. So if you wanted to enter your students now for unit 1 in the summer, they would have needed to have been taught through the forces, the electricity, the energy, and half of what we call solids, liquids and gases. Unit 2 has got the rest. It's got the waves, it's got the other half of the solids, liquids and gases, It's got magnetism, electromagnetism, radioactivity and particles, and astrophysics. Now, they are equally difficult. The content is different, but the level of demand is going to be the same. Some people say the astrophysics is hard. It isn't any harder than the electricity, right? The energy resources and energy transfer is no more difficult or easier than the waves. In Unit 1, we will be testing everything from grade 1 to grade 9. They will be the same level of demand. The proportion between how much is targeted at the lower, how much is targeted at the medium, and how much is targeted at high demand is going to be the same. So it isn't that Unit 2 is harder. Unit 2 is a different content. I would actually contend that many of the students find maybe Unit 7 there, magnetism and electromagnetism, hard, but they will also find that quite a lot of forces of motion, part C, shape, momentum, etc., is going to be difficult as well, because you've got momentum and you've got moments and so on. They might find that the energy is easier than the astrophysics. It's according to the student. So I'm going to say again, it is equally hard, right? And the content for separate science, again, is no more difficult. It is the same level of difficulty. We are going to demand to have them at the same sort of thing. I'm going to bring across a slide, which I hope you can see. And you can see this from another presentation, and that is looking at separate science physics, and all of the content, if you think of it as the outer circle. Part of it is a double award, and then single award science, which again not many students do and is not offered in modular, is a third of the content, right? So it's no more difficult, no more easy than any of the others. Okay, let's have a look at how you could do it. So this is how you could do it in your school. Okay, example 1, you could have Unit 1 at the end of year 10, Unit 2 at the end of year 11. Example 2, you could have Unit 1 at the end of June with a resit in November, and then do Unit 2 at the end of year 11 in the June. Or you could do, as some students do, Unit 1 and Unit 2, both of them in November, with the opportunity of picking up a resit if their grades are not as pleasing in June. It's up to them exactly how you structure this, but I'm fairly certain that the exams are available in both modules are available in June. I'm speaking to the chair. Right, how does our course fit in with the rest of the courses that Pearson offer? So if we consider that I'm looking down at this as it's sort of, to my mind, we should have done it the other way around. We've got slides going showing these, I presume they're Lego bricks or Lego lookalikes, showing that we're building up progression. And then the slide here is taking it from, if you like, from the international primary and international lower secondary courses, where we have content such as using the terms electric conductor, using the contents insulator, and then a little bit lower down in lower secondary, talking about the fact that there's a magnetic current, a magnetic field around it. having a look at IG, International GCSE, and then looking at how this works into the IAL and IAS content. So our exams are structured so they fit together. Our content is structured so that it builds on our ideas and progression further through. Right. Okay, let's go on to have a look at the planning at this point. Now, please make sure that you have picked up all of these contents from the course, from the delegate booklet or the delegate content here. We have provided you with a specification. We've provided you with a scheme of work. We've given you sample assessment materials. We've got the Getting Started guide and the course planner. Okay. So you should have got all of these from the more button on the Zoom, and hopefully you will be able to download them and use them. There's a lot of material. I'm not sure it's worthwhile printing them in the sense of most of them, the course planner and so on, are editable. So you can work on them on screen and then print what you need rather than printing what we've given you. You can reorganize them and restructure them and so on. So which of the documents do you plan to use? How are we going to have a look at, how are we going to use them? And let's have a look. Right, in the specification, okay, there are parts in the specification where they give you the international, that's what it looks like, right? They give you the qualification at a glance, the assessment information, right? So all of these are coming up. As they come up on your screen, these are from the website. This course materials are from the website. And these are some of the things that you will see in the specification booklet. Okay. You might, you as a teacher might not think, oh, I need to have this. Why choose? This is something that possibly your school makes a decision about, or it might be something that you put up for a parents' evening, that so the parents know exactly what the advantages are of choosing Pearson double award or the modular course. All right, this is for the double award here, and you can see that they got the content, right? And then this. I find these useful. I used to find these very useful to put up when I was doing a parents' evening, or when we had parents touring the school. I could actually show them these, and I used to laminate some of these so that the parents could actually see them and see how it fitted. So if you take this middle one in the middle here, which says how assessment relates to the qualifications, right? So this is a separate science. So if you're doing separate sciences, you need to take the 2 biology units to get biology modular, the 2 chemistry to get chemistry modular, and the 2 physics to get the physics modular. Those are both, all of those papers are 90 marks. The modular course underneath will be 60 marks. So to get double award in modular, you will need 1, 2, 3, 4, 5, 6 60-mark papers, which makes, again, 360, which is the same as any 2 of these. So the actual exam load is the same. Okay. How are these organized? I'm going to, let me just bring you one more over and hover this over the top. Okay, and let's speak to this one. If you find this a useful slide, this is taken from a presentation which was due to take place next week, but unfortunately we didn't get enough delegates wanting to take part. So it is going to run again in September. But if you wish to, if you wing a message to Tim, I'm sure Tim can organise this and give you that slide if you need to. If we take and have a look at this slide, okay, this is the actual paper 1, and then there's a similar one for paper 2. If you are doing modular, then this on your left-hand side, looking at the screen, the modular will have, right, 90 marks. Okay, 60 of them will be in the double award paper. So the double award paper is a subset of paper 1 modular. It will overlap with the linear by 30 marks. So 30 marks of the linear exam will be the same as the double award exam and the same as the modular exam. So there will be an overlap. This means you can't take linear and modular at the same time. Exams will be on the same day, on exactly the same time, right? And there will be that overlap of content. What we call the bold content, in other words, the separate science content, will be in paper 1, right? And it will be probably, well, I'll show you in a moment what is in the bold content. But as you can see, the modular will have 30 marks by itself, 30 marks which will be overlapped with linear, and a total of 60 marks overlapped with double award. Right? If I go on to the bold content, in the overlap and in the double award, there's no bold content. In the modular, there will be 30 marks of bold content. The bold content is if you like, the additional content between that and between double award and separate science physics. If we look at paper 2, okay, the overlap is different. Okay, the linear exam is 70 marks, of which 10 marks will overlap with modular. Okay, I don't know why I've got 100 minutes there. Yes, I think it is 100 minutes. Right, so the double award has actually got no overlap with the linear. Okay, so that's got some implications about what are the things. I'm going to take that to one side. Okay, so you can see that our content is going to be very similar to the content of the linear, and it's going to overlap in terms of the exam. Okay. This has got implications about your planning, about your building in revision time, about your support for the mocks, right? You need to know in the mocks, for the mock exams, that you're making your exam very similar to how our exams are going to be structured, okay? So that you're going to make sure that in your paper 1, you are only going to use the content from unit 1. Right, and not the content from unit 2, and that there is a reasonable amount of bold content. I'll remind you, bold is not harder. Bold is a different amount of content that is separate from double award. Double award is 60 marks. Physics is 90 marks. So there's that extra 30 marks, which is from the sections in the syllabus or specification where it is shown. Right, sample assessment material. Our sample assessment material that we've got is we're pushed for time. I know I'm speaking to some people before Christmas that they would have liked another set of sample assessment material. My answer is, I'm sorry, we are so pushed to actually produce these exam papers. Normally, the process for making an exam paper is a 2-year process. It may not seem like it at your end, but from our end, it's a 2-year process. The principal examiner writes a paper. He probably, for a paper of 90 marks, he probably writes 120 marks, 115 marks, thereabouts. That then goes to somebody called a reviser who pulls it apart and says, this is not going to work, that's not going to work, that's too hard, blah, 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 blah. The principal examiner rewrites it again. It then goes to a full meeting of about 6 or 7 people who again pull the paper apart, and at that point they also write a mark scheme and they finalize the 90 marks, and they make sure that a third of those marks are maths, and that 20% of the marks are practical, and that so many of the marks are at high demand, low demand, medium demand, and that the marks are spread more or less evenly over the topics, but you can't guarantee that. And all of this has to happen. It's like making a crossword. Once that we've got that paper, it then goes into the production process, and it goes back to the principal examiner at least another 5 or 6 times to check. Even something as simple as spacing, making sure that the diagrams is the right size, etc. It really is quite a process. So it takes us almost 2 years to actually make an exam paper. So to produce sample assessment material out of nowhere, when we are also writing materials for June, for November and June next year, is an almost impossible task. However, you have got Exam Wizard. You have got all of the past papers from the linear. The people writing them, the people writing the modular are senior examiners who have moved over from linear to modular. The chair of the sciences is one of my colleagues who was doing this presenter role with me earlier in the last year even, and he's moved over. He can't do it anymore because he gets to see the papers, right? So you have got masses of material on the website. Unfortunately, you've only got one sample assessment material, one paper, right? So as I've said before, 90 marks for separate sciences. We give you an extra 10 minutes. So 90 marks is, if you like, 90 minutes. And we are going to give you 1 hour, 40 minutes. So we're going to give you 100 minutes. So you've got a little extra time. Both papers will be the same length. They will both be equal to 50% double award. Each of them is going to be 1 hour, 10 minutes in length, 60 marks. So you get the extra time again. And you've got 2 biology, 2 chemistry, 2 physics papers, and each of them is going to be worth 1/6 of the total. Okay, that was very much like I showed you. Now, this is what you've got on terms, if you have a look for it on the website, sample assessment materials. It's got a lot of information about the content. I've looked at in detail at the physics ones. And the physics ones, I will say, are, I recognise some of them. Some of them are taken from previous papers, so there's nothing to stop you taking that yourself, previous papers. I'm going to say a little bit about how the papers are stored on the website. We have a system of locking the exam papers. Once they have been done, so November's was the last exam. November's exam papers are now locked until November this year. So November 24 will be locked until November 25. Now, locked means that if a student goes onto the website, they can't get that exam paper. They can only get that exam paper if you go to your exam officer and they give you a code and you can actually get that exam paper down. So it's locked. It's locked for teachers. Students can't get it, which means that you've always got secure material that you can base your mock exams on. Okay. So that's one of the things. So we always lock papers for a year. Don't know if that works for the other exams. Again, on the website, look for this thing where it says it's usually in this little box, course materials, and they've got an awful lot of material there for you. Okay, so how can you use them? Again, same problem. I can't see the chat, so you can chat away and put questions on there, and I will try and find them at the break. But I can't find them at all. So how can you use the sample assessment material? Well, the obvious one to do is to use them because these are not locked. These are open access. So if you use them as a mock exam, be aware of the fact that any of your students who are computer savvy, and most of them are, will possibly have looked for them. Sample assessment material is something I would actually, again, have if I'm having a parents' evening, parents' meeting, or I've got parents going around the school. This would be something that I would tend to have available so that your parents can see what this material looks like. It's quite interesting for them to see how exams have developed. The exam paper that they might have sat is a lot different to the ones that we sit now, even in just in terms of style, not so much the content, but the style of the exam and the fact that we structure and scaffold the exams to support the students. So personally, I wouldn't be looking at using sample assessment material as a mock exam. I would make your own mock exams either using Exam Wizard or literally doing a cut and stick on last year's papers. Okay. You could, however, use them for targeted revision. Right. This is the style of question that you're going to get. If you're doing this question, this is what you're going to get. This is sort of thing. If you are aware that a student is, shall we say, dipping in an area and you want to do an intervention with them, then that's a possibility of using this material as intervention. It could be support material if you're away for a lesson or two for whatever reason. You could also use them to monitor your student progress. It's quite a nice idea sometimes, especially when we're looking at topic 1 or unit 1, we've got our forces. To give some of the students a question from a sample assessment material at the beginning of the course, because we forget that forces in particular, they have probably done it in year 7, year 8, year 9, and we come in year 10 and we say, oh, you're going to start at GCSE physics, and we make them straight into forces again, and they think, how is this different? And this isn't. So sometimes we might want to use the sample assessment materials at the beginning of the topic, as well as maybe at the end of the topic. Right, our getting started course guides have got the introduction, they've got the content, they've got the core practicals, they've got assessment materials, and they've got the main changes. So what do they look like? We've got a content for modular, and then the double award. Okay. In the specification, we have got practicals, and we've also got now all our practicals. You will notice will have the words practical, and it would there is an exception to that one, And it's also in italics. So it's in sloopy handwriting, if you like. Some of them are in bold. Those are the content which you will find is in modular and not in double award. So if you do it, it's also got a P for physics. Well, I'm making separate physics, not just double award, separate physics. And there's a whole range of these practicals. So how many in total? 12 in double award, sorry, in physics. Right? You will have 2 which are in bold. So the other 8 are in the double award. So each of these. Now, I don't know whether it's sneaky or not, but if you have a look, there's a couple of things in the physics where we've talked about recognizing, I think in the electricity, it's something about recognizing the voltage current curves for different devices, like a lamp, an LED, a diode, and so on. I would suggest you find it really hard to do that unless you do the practical. Don't just give them the graph, make sure they do the practical. And there's a similar one in the unit 1, okay, in the forces section. Although this one, investigate the motion of everyday objects. Ooh, how wide is that? Okay. Again, you've got all of this information. We've been giving it to you as a handout and the delegate pack, but you've got this information here at this point. Right, I am going to, it's a few minutes before 10 UK time. So I'm going to suggest that we have a short break for 5 minutes, and I'm hoping that in that meantime I can find the chat. So I make it 2 minutes to 10. Can we come back here at 10:05? That gives you a 7-minute break, please. My assistant here, who's doing the technical support, Faina, she and some of the other people I've worked for, I don't know how I'd survive without them. I've now managed to find, I don't know where chat was hiding, it just disappeared off. I've now had a read through it. I hope, Duncan, I've actually you've now got the reason for why we lock the papers, so that you've actually got secure papers that the students can't get at, which is actually quite important. Okay. So having looked at the getting started, one of the things to do with them is to think about which parts of that getting started. I'm going to go back. They've got the practical in there, they've got the content in there. Which of the things which is most important? Now, to me, I've always wanted to integrate my teaching with my practical. I did retire from teaching a little while ago because I have a form of arthritis, which means that oh, they've changed my medication. I'm a lot better now, but I found it even difficult to hold open crocodile clips and doing demonstrations. And this really affected my teaching because I had a practical for virtually every single lesson. And if I couldn't get across the room fast enough, I didn't feel that I was doing my job as a teacher, which is one of the reasons I retired from it. So I always want to integrate practical and the content together. And that's what I found I needed with the Get Started guide, and in particular with the guide which has got the course content, and you can sort of have a look at the scheme of work. The fact that this is editable is really helpful. The reason for this is I'm not sure where everybody is. I did notice that Claire said she's got SEN students and so on, but looking at some of these names I've got down here, you're from a whole range of different places. Now, if it's coming up to Ramadan, for example, if you are teaching in a largely Muslim school, what is Ramadan? How is it going to affect your students? Some of these at 15 and 16 are certainly going to want to have to go through fasting, and so on. How's it going to affect what you teach at that point? Now, if you've got a section which you can either do self-teaching from the students, a lot of them, for example, like the astrophysics, and quite a lot of the astrophysics, you can set them as almost homework tasks. So you can alter your scheme of work to fit in with the needs of your students and the needs of your parents and the needs of your school and the area that you're in. Okay. The scheme of work has got large quantities of assessment of activities that they suggest. So has the textbook. The textbook has an active guide so that the students can access this online as well. Okay, because it's a flexible scheme of work, you can edit it to make sure, if you want to teach it in 1 year, 2 years, if you want to teach it in 18 months, you can edit it to that amount. We have built in revision time. How you do the revision is very much up to you. I'm one of these people who think that revision is as important as teaching, and that it should be heavily targeted, and that you, for example, don't just say, oh, we're going to revise forces. Then what we do is maybe we revise all the questions with calculations, or we revise all the described questions or all the explained questions. So I do it in a slightly different way. But your scheme of work is there, right? It is editable. You can organize it, you can structure it. The person who needs it most is quite often the lab assistant, because they will need to know. So this is some of the things that we actually have in the scheme of work. So let's have a look at, say, topic 5. Right. So we've taken a section, the first column here is going to be what the content is, right? So those are that's from the specification. The specification in physics always has this over 1.1, 2.1, and so on. They tell you what units we're going to use, and we expect them to use that unit. That's a really good lesson. That's a really good lesson for doing revision, and that is using your units. So we suggest different activities. Now, not all lessons we're going to have all of this, right? There's various simulations, there's various class practicals. I looked at this and I thought, oh, ticker timer. How many people use a ticker timer still? I'm not so sure, right? So these are from these link to them in the next one. The ticker timer graphs, moving man simulations. This is what we're actually targeting. Now, when students sometimes ask me, why are we doing physics? These 2 columns are why we're doing physics. Problem solving. Because if you do physics, you can look at problems. We're teaching you analysis. We're teaching you about adaptability. We're teaching you about decision making, and we're teaching you about critical thinking. These are the reasons we do physics, not just the content. The ones who say, oh, I'm not going to be doing physics at A level, but this is the reason. This is the skills. Some people call them soft skills. I'm not sure they are that soft. So if you have a look at the the topic 5, you've got another demonstrations on this. So there's a whole range of things that they've done. We also build in consolidation time, assessment time, revision time. We put suggested activities for these revision times. They are built in. It's not perfect. There are things you're going to say, oh God, I wouldn't do that. Oh, no, 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 no. There may be things which will make you think, oh, no. But it gives you a starting point, and it's comprehensive. Now, I think that's the important thing. If I'm doing a scheme of work for myself, I will check it against this because I want to make sure that I've covered everything I need to. This scheme of work is comprehensive. It is flexible. You can use it the way you want it. Okay, we've given you, as you say, as I'm clicking through, it's giving you the topics, the specification, the activities, resources, skills, all of the things that we want, and it links to the textbooks, and it also links to something we've introduced recently, which is called the Teaching Hub. I'll speak to you about this a bit later. It's a bought in. Oh, it's quite fun. And all of these things coming up. Let's click on to the next slide. Right. All the content is the same. Yes. I keep saying this and so on. Right. We've got course planners. Course planners are similar to the scheme of work. All right. They look a little different. To my mind, I would tend to start with a course planner. It's quite useful here that you can see the topic. You can it gives you year, term, week, subtopic, spec points. I would choose to do this first. I wouldn't normally do it. I wouldn't normally teach topic 1, topic 2, topic 3, topic 4 in that order. I would actually put them in the order I want to do them. I might only do 2 or 3 lessons out of topic 1 before I move into another topic. But this overall planner is where I would tend to start. Then I'd probably go back to the scheme of work and make sure that I've covered everything in, right? So you've got a double award planner, right? Deliberately not units 1 to 6, right? Okay, so it's actually, if you're not the only physics teacher in the school, it's something that you should be talking through with your other colleagues and making sure that you are all on the same page, that you're all working in the same sort of way and doing your planners on this. Okay, there's loads of material in there. Now, this activity is put in as an activity that you should be doing with your department, or an activity that you should be looking at if you're the sole physics teacher, that you should be looking at afterwards. You're the one to do it. Look at the specification points. Choose a topic that has a different number of points between the linear and modular waves, right? Look at the scheme of work, look at the course planner. Think about, when did you last teach it? What worked? What didn't work? Add into the things. So although it says add it to the chat box, I actually do feel that this is some content that you should be doing with your colleagues, sitting there so that you can talk. If I were doing a face-to-face presentation with you, at this point we would have a 10-15 minute break with the packs out, and you'd be doing it with a pen or with your laptop, with your iPad or whatever, right? And it's got to be specific to your school. Think about the documents you could use. Think about the things that your examples that you're going to be using to actually bring out the things that you actually wanted. You want some sort of things to have a look at. Right. Okay. What about doing the content with the students? Right. So that was what I was saying. The last activity, excuse me, there. The last one is something you should be doing with your colleagues. So what do you do with your students? Now, okay, I think that students need to know where they're going. Some students are, some of the more able students, you can give them a specification and they're quite happy about that. I would suggest that quite a lot of students, certainly at the year 10 stage, do not need the specification in their hands. What they do need is a check sheet. Right, excuse me, I'm going looking for another slide. If I can find it. Sorry, apologies. I'm flicking through this. I thought it was. Yes, I got it. Right. This is the sort of thing that I think students need. Now, I made this up from, I mean, literally, it took me about 2 minutes to make this sort of thing. Okay, this is from Separate Science Physics. It's got the P, that means it's a bold content, and so on. So I picked up some of the content, 4 specification points, right? And I just given a smiley face, a neutral face, and a sad face. Okay. And I'm actually use this as something that the students can actually fill up either during their revision, and hence when they bring it back to you, they've got this information. You can say, okay, 3/4 of the class don't find this are not very good with this, and then you know to target that section. Or you can give it to them at the beginning. This is the content. This is what we're going to be doing. Tell me about how you feel as you're going along. Okay. And then I'm going to talk to you about whiteboards. Okay. I'm sure all of you use a whiteboard, but I don't know if you use a whiteboard A4 size. Right. An A4 size whiteboard can be used so that you put one of those questions up on that. How do you feel about the relationship between so and so? So the student writes on the whiteboard, and they maybe have a smiley face on this. They hover the questions with the whiteboard, and you all show it at the same time. So you can all show the content at the same time. Now, this is what we talk about metacognition. Getting them to evaluate their own knowledge and their own learning on a topic. So if you give them a check sheet at the beginning, then you can also help them to see how they're progressing through this, get them to assess their weaker topics, get them to... Now, these quizzes take you almost no time to make. They're very, very straightforward and so easy to do. Okay. There are obviously lots of other ways of helping students with the content. Yeah, that's an entire presentation about helping them, but that's a simple one that we want you to introduce on the idea. Oh, practicals. Right, there are lots and lots of information about practicals. Now, supporting practicals. what do we mean when we say practical? If we have that list of 12 practicals, the content that we have from the, again, excuse me a moment and see if I can, okay, I have got the core practical guide up and I'm going to, oh, it's the core, excuse me, I'll show you on here anyway, you can see. The core practical guide looks like this, okay? And it gives you when they've got them. This is the first edition. It's in an Adobe, a PDF document. There are 200, over 200 pages. So if I skip through, you can see that they list the biology, the chemistry, and the physics. And there's also got apparatus, equipment, and so on. So let's skip to, let's do 151. Actually, I thought I was getting, actually, it's not a bad idea. Core practical 2, right? And they have got, I'm going back through it. I apologize if it's making you feel a bit nauseous. I was intending for the beginning of this. Core practical 1, motion. They've got the links to the specification content, right? And they have suggested dropping the ball from various heights, rolling a ball down, toy car down a slope. Useful. The amount of toy cars I got through, you know, it's much more accessible than using toy cars. Thank you, find that you're actually reminding people they can get it. I want to show this particular one. They've got this has got links to Institute of Physics, right? Which are again useful. Now, the thing to talk about is, right, the questions that you ask during the practical. Yeah, you all know how to do a toy car down a slope, but these are the questions. How do you make sure that your starting speed is 0, right? If it's right, what can we do to make it a more accurate time than using a stopwatch? Why should you measure from the bottom of the ball or the front of the car and so on? What happens if you use larger distances? We put in suggested questions, we put in skills which are taught. We link in the math skills that they should know. And more than that, we give them the style of question. Now, again, these are taken from old papers. The style of question is very similar. Right. We were stopped doing this sort of thing with a student there, but it's still a relevant style of question, right? You will notice that we're never asking a formal, if you like, write out the method of an experiment. Even here, describe how the students could take the measurements needed to find the speed at the bottom, and you should name additional equipment. Right? Then they've given you the mark scheme. And let's think about is suitable equipment, detail of measuring the distance, detail of measuring the time, detail of experimental setup, right? There's one on the core extension, on the extension. That's this one is the basic Hooke's law equipment. Again, you've got questions, you've got skills, you've got the maths things. We've put into it an exam paper question. I recognize that one. So when we're talking about practical, we are in Pearson are talking about 20% of the exam that we test the practical skills. So if we look at this question, right, how can they improve quality of data? Right? That was fairly straightforward, isn't it? They should start maybe doing some, thinking about averaging, taking more data. We've gotten them to do a curve, drawing a curve, plotting data. This one is discussing, supporting your argument. This is what we mean when we talk about practical skills. We have the opportunity to test the skills that you've taken. Your opportunity is to actually give them a practice on this. Now, there's 12 that they have to do. We've supported. We've given you the basic idea. We've given you links to the IOP. We've given you links to other sections. We've given you past papers for all of this, how we are testing them here, the mark scheme, etc. Right? So you've got an enormous resource that's actually available. However, teachers come to me and say, excuse me, how do I teach it? And this is how you teach it, right? When you're giving your practicals, you actually make sure, you actually make sure that you are providing what we call scaffolding. And scaffolding is, if you like, the underlying structure that, if you like, we are training them to. So what is the independent variable? Which two variables should I control? Give them a hypothesis. This one is obviously from biology. As the light intensity increases, the rate of biology production by the pond wheel will. Circle anomalous values, two sources of error to make it more reliable. So you give them this sort of thing. Now, it could be a handout. There is nothing wrong with a handout. There is nothing wrong with projecting this series of questions onto your whiteboard and letting them do it. There is nothing wrong with putting those two questions, like the first one. Sorry, I'll get it again. Independent variable is, get them to write it, hover so that nobody next to them can see what they've written, and then they turn it forward and show you at the same time. That gives you an immediate feedback. So all of these are things that you can do to do the practical. When they become older, or if you're more able, you can basically gradually reduce the amount of scaffolding that we ask, and until your questions that you're asking them are the same sort of questions that we would ask them on an exam paper. Evaluate your results. We could have evaluate the data and and deduce whether the student was correct or not, right? So they will have done this planning and done this presentation. They will have done this work. The problem is, right? The problem is, before I move off practicals, what happens to those practicals that you don't actually have the kit for, or like an oscilloscope? Most schools do not have more than one or two oscilloscopes, unless they're doing A-level, and they may have 3 or 4. There may be other equipment. You may find that doing the radioactivity, for example, is difficult because you can't get the radioactive sources. There's always a video. There are some resources on our website as well that link. But in addition to this, I'm bringing out this one is a paid-for resource. This is from a company known as Focus e-learning or Focus Education. They have given me a demo account, which is nice because Otherwise, I could say this costs £100 per year for the entire school, for all of these packs, for you, all your teachers, and all of your students. Obviously, if you've got a big school, it's far more worthwhile than if you're a small school with only 20 students per year, but it's still a worthwhile resource. So I'm going to pick up some of these. I'm going to pick out, I think I might go into this one. Modern, oh, excuse me. So, okay, let's go into absorption of gamma rays, for example. This program provides you with a simulation where you can take a GM tube, right, and it says drag on the ruler. So you can move your GM tube up and down. You've got a screen there so you can see the exact measurement, at least to a millimeter. You can change the thickness of the LED screen. I hope you can notice here, the absorber. You can actually get them to do a measurement of background count. Right, let's do it in times 10. Right, so it will do a minute count in 6 seconds. So you can repeat that, obviously. If you are not measuring, notice when you did the background count, your source disappeared. Put it back. Have a look at this again, and let's do another. Right, and so on. So you have got a means of doing some of the radioactivity. Sorry, it's not going to work until I do that. Okay, that takes you to a big screen. So if you wanted to do it in class, you can do it in class. Thing is that the students can also use it. They've got the theory. Okay, some of this is designed for A-level, but you've got the apparatus. This is what it looks like in reality. You've got safety precautions. So there is one radioactivity. I mean, it's something that people can't necessarily do. So I am lucky enough to get, as I say, get a demonstration account from this, which it isn't an expensive thing, and I do not get paid by that particular company. I will say that. I am paid by Pearson. I'm not paid by Focus. But it is one of the resources. If you go looking, you will find there are virtual oscilloscopes. There's one by a university in Chile, I think, that actually has this. Now, right, okay. Our next thing we're looking at is what we call taxonomy. Essential. A taxonomy is the command word, right? Every question has a command word, and we never have more than one, right? It tells them what they should do. If they don't know what that command word means, they can't answer the question. The ones that get confused are describe and explain. Describe means paint a word picture. Explain means give me a mechanism, give me a process. First this happens, then that happens, then that happens, or this happens because this. The word to look for in explain is because, or so that, or thus, or and so on. All of our taxonomy is the same for biology, chemistry, and physics. They're all there at the back of the specification, and we will use them all. We will use all of these different taxonomy words. These are the ones that they actually ask. So multiple choice. If it's multiple choice, we will ask words like what, why, which. Which of these is? Okay. There are a few which has a command word. We will say analyze the data to explain. So I suppose in a sense it's almost, but we're telling them, look at the data, use the data and explain, right? Deduce means draw a conclusion. Now, we're possibly not as fussy at IGCSE level as it is at A level. At A level, which I've been marking recently, if the starts with the word deduce whether the student was correct. If you don't write a conclusion, like, and so the student is not correct, you won't get that final mark, right? Determine is, there's going to be some sort of maths in there. We had a similar question to this between deduce and determine, and that was in the June exams where we talked about students going away with a power pack and whether the power pack would be enough for the week, and they had to determine whether or not. So we're not telling them exactly what they've got to do, but they've got to work it out. Similar one is evaluate. If they don't know what evaluate means, right, we need to practice. Assess and deduce. Assess. We haven't got assess in our list. We have analyze. Analyze means it means have a look at the data, see if you can find any patterns. That's usually what analyze means. See if you can find any patterns, see if you can find something that stands that doesn't fit. So that if we had analyzed the data or analyzed the graph to explain whether force increases, whether extension increases with force, we would expect them to have a look at the graph, look at the shape of the graph. Is it a straight line graph? If it's a straight line graph, say it is proportional. If it's a straight line graph that goes through zero, we'd say it is directly proportional. And we would expect them to bring together. So it is a question which will be targeted at a higher demand, because it is going to be bringing together two or three different things, right? Discuss. Discuss means, well, they've got, as you say there, it is ideas like, discuss the differences between, I don't know, let's just pick, oh, I think that was more or less, I was thinking of a biology content there. Okay, let's do an astrophysics sort of thing. Discuss the differences between a red giant and a white dwarf, right? So you would actually, in that case, you would identify factors which you do or the students should know. So they should know about the temperatures. They should know about the sizes. They should obviously know, well, we've given them the colors. And we should talk about them being where they are in their life cycle. So we would actually expect them to use the information they already know and maybe do a comparison. So that would be a discuss. Describe. It it doesn't have to have any reason. Doesn't have to have a justification. So it's less detailed than explain. I would also think it might be easier if I had a question with that at the moment. I see if I don't know if I've got anything that's I've not got anything easily accessible at the moment that I could actually show you. Make a query about that if you wish to. If you want more information, make a query about that when I show you the information about Tim, and ask him to guide it to me, and I will I'll give you an example from previous questions with some student information. I can do that later, but I can't really do it in the middle of the content, in the middle of this. But that's something else. So anyway, as I was trying to say, the command words are really quite important. If you have students as a targeted revision practice, right? I wouldn't necessarily say all of these, but if you were to photocopy this, split it into or not say photocopy, but put all of these onto equal size cards, for example, and ask students to match them. Match what does the definition, which definition goes to which command word, right? And maybe, it's not, I think it's a task which they should do in groups of 2 or 3, because I think it's something that they should talk to each other about and so on. Okay, that's, but we use them in biology and chemistry and physics. So whatever your biology students, your teachers, your chemistry teachers are doing, make sure that they have the same understanding of these. Right, math skills. Okay, math skills are vital. 30%. Now, this is where we do differ between biology, chemistry, and physics. In biology and chemistry, they don't have as much maths content. We have an awful lot more maths content because over the double award, 20% is meant to be maths. So 30 in physics, 20 in chemistry, 10 in biology. However, we test the skills the same way. The graph plotting is the same. That's why we no longer have, we used to get more than 1 mark for plotting data, but we no longer do. Okay. The content is that. This is in the specification. So which is biology, which is chemistry, which is physics. And you can see that all of them, all of them virtually are physics. Now, understand the principles and sampling is not physics. Right? Understand the terms mode and median are not physics. Right? But we will use the term mean. We're not going to be using the terms mode and median. It doesn't. It's not relevant to us. But we will find that we need that as I say, all the biology content is far less content than we've got. The important thing is, as far as we're concerned, as a physicist are concerned, is can your students substitute dimensionally correctly? So if they're doing a substitution, that substitution has got to be, if they're going to put in a volume, they've got to put in volume. I have been marking recently a BTEC paper, and they actually had first stage in the calculation, they had to work out the volume. Many of them didn't do it, and they substituted a length into a volume. They're not going to get a mark, and that's wrong physics, and that's going to go from there. Now, there is this guidance in the Maths for Physics. Now, you give me a moment, and I will bring up, I hope I can bring up, excuse me, yep. On the website now available are a whole set of guides, right? These are taken from the original guide. This is one of them, and I think it's quite useful. These are shorter guides, 2, 3, 4 pages. They are targeted to specific areas that we think people have had problems with, and they are designed to hand out to students. They have been written by one of my colleagues in who was marking with BTEC with me, I think. Maths in Science standard form. This, as you can see, this one I really liked because he's taken how to do it on a calculator, right? How do you enter it? We find that students do not know how to use a calculator to do standard form. So that's one of them. He's given a worked example and some questions. Obviously, he's not going to do just the physics, because chemistry also has the problems about standard form, and he's given a link, he's given the mark schemes. There's one on graphs, which I think you can see. Again, it's designed for the whole of the sciences. It's not just designed for physics, but it is a very, very useful piece of information designed to hand out to the students so that they can see what they're getting and so on. Now, they are very, very recent on the website. Let's see, there's one on decimals, on rounding, again, an area. Students have lost marks simply by not doing the rounding correctly. Okay, again, it's designed for all of the subjects. It's not just designed for physics, but I do suggest it's material that you really should be looking at and maybe working out. There was one which is more biology, which is sampling. I think I've got that one. That one was, how many have I got? I think there's 5 of them. 1, 2, 3, 4. Oh, yes. Oh, this one is essential, significant figures. Another area that we in physics tend to have one question where significant figures are important. And we ask the answers to come into student figures, right? So, designed for your students. The entire booklet is much more extensive. And I would suggest that is something that, again, you should be looking at with your department rather than just, again, it's not, I don't think it's really for students. I think it's for yeah, it's for your department rather than students. So, okay, I have about a few minutes left. Okay. Seem to have jumped to the end. Right, okay. What support have we got? We've got the getting started guides, the events, We've got schemes of work, skills mapping, exam wizard, mark schemes, results plus, etc. There are some things which you will actually pay for if you wish. That's an addition, but most of the material on the website is all of all the course material, and you can see there's enormous quantities if you look at. Don't forget to look at the linear. Don't forget to look at home as well if you want to. You've got the documents. All of this is freely downloadable. Results plus, as I say, we do know that there's a few hiccups when there's people going through the British Council, but if you can access it, it's excellent for finding out what your students don't know. So the student takes a paper. This is a part in the UK. It's called Hellaby. All the exam papers are they take the staples out and they scan them. They can scan 10,000 papers in an hour. When the students work, or when the teachers mark, we only mark a section on the screen. You can get your results on this sort of results plus, and you can see how your students compare to each other and how your school compares to other schools. They won't give you the names of other schools, which is one of the problems. Exam Wizard, again, is an online tool. It gives you you can search it to find the topics you want, the level of demand you want. You get the mark schemes if you wish to. You can get. It also gives you the examiner's report, and it enables you to make your homework sheets, you make your exam papers, or even just simply, slides for your presentations. This one is useful if you want to have a look at if you've got a student and you think, oh my goodness, he should have got grade 9 or she should have got grade 9 and they got a grade 4, you think there's something wrong. You can have a quick look at this access to scripts, right? And it's available on results day, right? And you can see what has actually happened to that things. There are things that in addition to all this free stuff, you can pay for. This is a new one called Teaching Hubs, relatively new, right? So this is what our textbook looks like. I do know Steve Woolley and I do know Penny Johnson. I haven't met Brian Arnold, but I have textbooks that he wrote and I used to use them in class. So it's a material that you can use. It's quite extensive. And in addition to that, it has an active book, so students can link onto it. Teaching hubs are, I believe, I did look at this, and I think a figure of about £800 comes to mind. But please don't quote me on that. I think it's there, but it's a new resource, and what I have seen, I have been impressed with. I haven't seen a vast amount of it. And last but not least, this is the guy that you need to actually email if you have any specific questions. Tim doesn't always know the answer. He will tell you this. He does all the sciences, so he doesn't know everything about everything, but he does know who to ask, and that's a more important thing. So if you want to contact him, the easy way of contacting him is either qualifications.pearson or teachingscience@pearson.com. If you want to book into time with a subject advisor, you can actually click onto that link and get some information about that. Okay, now any questions that you have, if you want to put in I'll leave that one, but put any questions in the chat. If you want if you want those extra additional slides that I showed you earlier, if you contact Tim, Teaching Science, he can give you those specific slides about how the content of the exams overlap. I know somebody wanted to know about the difference between assess and deduce. I think that's a really good question. And I think it's something that I will actually write myself down as a specific task, because I think I will need to do that certainly before I go. Right, I'm going to write that down. Produce a worksheet for explain, discuss, deduce. Anything else? Yeah, I'll try and put together a specific worksheet on that. Okay, so we're now at 1 minute to 11, which is when I should be saying thank you for your attendance and thank you for your attention, and I hope it's been useful.